In section 4.3, example 3, so this one says to write this given function as a composition of two other functions. So the function that they're giving us is 3x squared minus 7 raised to the power of 2/3. Okay, so the idea here is that we're going to try to find two other functions that when we compose them together, we get that one. So really what we're looking for is we want to write the given function as y equals f of g of x. And the goal here is to figure out what that f and g are going to be. So really, I think the best way to approach this is just notice that you've got parentheses here. You've got a function within the parentheses, and then you've got another function up here, the exponent part of the function. So if you just look at what's in parentheses, that's really a good thing to make g. So if we make the g function the 3x squared minus 7, and then if I make the other function, the outer function, so-called outer function, if I just make that x to the 2/3 power, then notice what happens when I take that one and I plug it into that one. I'm going to get exactly that, right? So then f of g of x is equal to, again, I take the g function and I insert it into the f one, so I get 3x squared minus 7. That's the inner function raised to the power of 2/3, and that 2/3 power is the outer function. So this is really important to be able to do this when we're actually going to be taking derivatives using the chain rule, to be able to identify that you actually have a composition of two functions, and then how do you deal with that when you want to take its derivative.